we shall be looking at a very important topic in mathematics. That is sequence and series. Alright, so here is the sequence and series. So this is the topic that we are going to look at today. So first of all, we must understand what is a sequence and what is a series. So let's start with a sequence. We say, what is a sequence? We say a sequence are numbers that flows in a particular pattern. Again, we say a sequence is a number that flows in what? In a particular pattern. Alright? So now, we say they are numbers that flow in a particular pattern. Now, which pattern are they flowing? We don't know. Alright? But in mathematics, we have different ways in which numbers are what? Or we say we have different patterns in which numbers are flowing, or we say what? We have different patterns. Now, what are the patterns here? Now we have even pattern and we have all patterns or all numbers, and we also have what? We say we have prime factors, or we say what? We have prime numbers. Alright? So therefore we say this is prime factor, or we say prime numbers. Now let's start with what? With the even numbers, or we say even patterns. Now we must understand what are even numbers, and we must also understand what are odd and prime numbers. Now, when we say an even numbers, we say even numbers are numbers that can be divisible by 2 without a remainder. We say even numbers, we say these are numbers that can be divisible by 2 with no remainder. Example of an even number here is 30 all over 2. Because we say even numbers are numbers that can be divisible by 2 without no remainder. It means when we divide 30 by 2, we are going to have what? A whole number as what? As our answer. Now, we say 30 divided by 2 here is equal to 50. Alright? Because 2 is how many times 1 times, and into how many times? So 15 times. And 15 divided by 1 here, we are going to have what? 15 as an answer. So, this is just an example of an even number. How we understand the even number here? Let's go to odd numbers. We say, what are odd numbers? We say, odd numbers are numbers that can be divisible by 2 with a remainder of 1. Odd numbers, these are numbers that can be divisible by 2 with a remainder of 1. Alright? Or if we say we don't give the remainder, it means we are going to have what? A decimal as what? As an answer. Example here. We say this is 30 here, or let me say 35, all upon what? All upon 2. Alright? Or let's take a simple number that all of us can understand. Let me say we have 3 all over 2. Now, we have 3 oranges, and we are asked to divide these 3 oranges into what? Into 2 equal halves. Alright? Now we have 3 divided by 2. That is the interpretation. Now 3 divided by 2 here is equal to what? Now 2 divided by times 1 time. Into how many times? We have 2 times remainder 1. Alright? So in this case here, you can find out that when we divide 3 upon 2 here, what do we have? We have 2 remainder what? Remainder 1. So that is odd number. We say odd numbers are numbers that can be divisible by 2 with a remainder of 1. Alright? Now, since we have understood what are odd numbers and prime and even numbers, let's go to prime numbers. Let's explain briefly about prime numbers. What are prime numbers, or say prime factors? We say prime numbers or prime factors are numbers that has only 2 factors. We say prime factors are numbers that has only 2 factors. One and the number itself. Right? Prime numbers are numbers that has only 2 factors. 1 and the number itself. Example here is, now we have 11. 11 is a prime factor. Alright? But how can you tell that 11 is a prime factor? We can only tell if at all it has only two factors. That is 1 and itself. Now suppose we say 11 times 1. What are we going to have? 11 times 1, we are going to have 11. Do you have any number that you can multiply to give us 11? The answer is no. So since we have no other number that you can multiply to give us 11, we can say 11 there is what? Is a prime factor. Alright? Even 2. 2 is an even number and it can also be what? A prime factor. Alright? Example here, we say this is 2 multiplied by what? By 1. 2 multiplied by 1 can give us 2. Alright? Do we have any number that you can multiply to give us 2? No. We only have 2 and 1. That's why we say what? Prime factors, we say are numbers that has only 2 factors. 1 and the number itself. Alright? So, if we have understood this one here, this is all about what? About a sequence. We say a sequence are numbers that flows in a particular pattern. So, they can either be what? Even numbers or even pattern, odd pattern. Right? In most cases, the prime factors can work with what? We say odd numbers. Now, let's go back to our definition, to our sequence. We say a sequence here are numbers that flows in a particular pattern. We say sequence, so these are numbers that flows in a particular pattern. Alright? Now they can either flow in the odd pattern, even pattern. Now, we have talked about even pattern. We say even pattern or even numbers are numbers that can be divisible by 2 without any remainder. Alright? Now we have 2, comma, we have 4, comma, we have 6, comma, we have 8. Alright? But mind you, we say what? A sequence are numbers that flows in a particular pattern. Alright? And I said, they can either be what? Even pattern, odd pattern. Right? In most cases, the odd pattern and the prime factors, they work together. Alright? In most cases. So in this case here, suppose we say we have 3, comma, we have 5, comma, we have 7, comma, and we have 9. Now looking at the pattern here, all what we have on the board here is what? Is a sequence. And they are flowing in what? In a particular pattern. Alright? So that will say a sequence are numbers that flows in a particular pattern. They can either be what? In pattern or what? Or odd patterns here. Now look at what we have here. We have the numbers, they are flowing what? In a particular pattern. And here we have what? And top we have an even pattern. And at the bottom what we have odd patterns. Alright? So again, for the sequence here, we say each numbers here or members here are called terms. Alright? Now we have this one here as what? As the first term. We have this one as the second term. We have this one as the third term. And this one as what? As the fourth term. Likewise here for the second one. Right? So in this case, this is what? This is term 1. This is term 2. This is term 3. And this is term 4. Alright? So since we see there are number that flows in a particular pattern, now we say each members here or numbers here are called terms. We have term 1, we have term 2, we have term 3, we have term 4. Alright? It can be continued. Alright? So in this case here, this is all what we have to learn presently about what? About our sequence. Now, if we have understood this one, let's go to what? So a series. Alright? Now what is a series in this case? We say a series here is the algebraic sum of a sequence. We say a series is the algebraic sum of a sequence. Alright? I made a mistake. I take this one off. For, let me write them again. 6 and 8. We have 3, 5. We have 7 and we have 9. Now, we have talked about sequence. So, we have talked about a sequence. Now, let's jump towards a series. Alright? We say a series is the algebraic sum of a sequence. We say a series here is the algebraic sum of a sequence. What do we mean by that? Mind you, in mathematics, when we say sum, it means we are to add. Alright? So if now we are saying a series is the algebraic sum of a sequence, what do we do? Now we have the sequence. Alright? Now let's take the first sequence here. For the first sequence, we have 2. Alright? But we say it's the algebraic sum of a sequence. Now we say this is the sign of what? Of sum. Now we say this is 2 plus 4 plus 6 plus 8. Alright? So this is what we pass as what? As the series. Because we say a series is the algebraic sum of a sequence. But finally, we have other values here. What are the values? We have 3 plus, we have 5 plus, we have 7 plus, we have 9. Right? So we say a sequence, a series is what? Is the algebraic sum of a sequence. Alright? Now we have a sequence. Now we have converted the sequence to what? To a series. Alright? Now, have we understood this one? Let's jump to what we call as what? As the types of a series. Mind you, we have 2 main types of a series. What are they? We have the finite series. And we also have what we refer to as the infinite series. We have the infinite series. Alright? Now let's talk about the finite series. What are finite series here? We say finite series here is where we can count the last term. We say a finite series is where we can count the last term. Or we say where the last term can be counted. Alright? Or we can say a finite series is where the last term is known. Alright? A finite series is where we can count the last term, or is where the last term is known. Example here. Now we have 2 plus 4 plus 6 plus what? Plus 8. Here, if we are asked, do we know the last term? Yes, we know the last term. Right? The last term here is what? Is 8. So in this case here, we can call this series as what? As a finite series. Alright? So here we have the finite series or the finite series. Alright? This one also here, we have 3 plus 5 plus 7 plus 8, plus 9. Here also, we know the last term. Or we can count the last term. Because this is what? T1, T2, T3, and T4. So since we can count the last term, or the last term is known, therefore, we can say this is what? A finite series. Okay? But suppose we don't know the last term, or we cannot count the last term. How can we call that particular series? We can call it as what? The infinite series. We say an infinite series here is where the last term cannot be counted, or where the last term is unknown, and it has a specific symbol. And what is that symbol? It is denoted as what? As 3 dots. Example. Let's take an example of what? Of an infinite series. Now here, if we want to make this one to become an infinite series, what do we do? Now we say the series here is the algebraic sum of a sequence. Now this is 2 plus 4 plus 6 plus 8. We have dots, dots, dots. Alright? And when you see these 3 dots here it means it continues. Alright? Here 8 is not the last term. 8 here is not the last term. The last term here is unknown. That's why we denoted what? The 3 dots. So indicate that this is what? An infinite series. It means it continues. Or we cannot count the last term. Okay? Where we can count the last term, because that particular expression is what is a finite series. And where we cannot count the last term, or where the last term is unknown, or where we see 3 dots, it means that particular expression expression continues. We don't know the last term. The last term that is what? Is unknown. It cannot be counted. Alright? So, after we have understood this one here, let's go to what we refer to as well the types of sequence as well. Now, the types of sequence here, we say we also have two main types of a sequence. What are they? We have the linear sequence. Linear sequence, or we can say what? The arithmetic progression. Arithmetic progression. Or we say what? We can call this for short, say what? AP. We have the linear sequence, or we say what? The arithmetic progression. Alright? We also have what we refer to as the exponential sequence. Exponential sequence. Or we say what? The geometric progression. Geometric progression. Or we say what? GP. Alright? So we have talked about what? The types of series. Now we are on what? The types of sequence. We say we have two main types of sequence. What are they? We have the linear sequence, or we say what? The arithmetic progression. And we also have what? The exponential sequence, or we say what? The geometric progression. Alright? Now, let's start with the linear sequence. We start with the linear sequence here. We say, what is a linear sequence? We say a linear sequence is where we have a constant common difference. Alright? Or we say a linear sequence is where any number has a constant common difference. Alright? Example here, we have a sequence here. Alright? And we have a common difference here. Because all of these expressions here are in what? In an even pattern. Alright? So therefore, we can say we have a constant common difference here. One constant common difference here that we have is what? Is 2. Alright? So say where we have a constant common difference, we say we can class that particular expression as what? As a linear sequence. Example. First of all, let me show you how to find a common difference. To find the common difference here, we say Tn plus 1 here minus, we say Tn. Alright? We say Tn plus 1 minus Tn. What do we mean by this one here? We say this is T2 minus T1. Or we can say T3 here minus T2. Or we say what? T4 minus T3. Always we subtract from what? The preceding terms. Alright, now here we say, earlier on, we said what? Each member here or numbers here are called what? A term. Alright, so we say this is the first term, this is the second term, this is the third term, and this is the fourth term. Alright, so here let's take this one here. This is T1, T2, T3, and we have T4. Okay, now according to the formula here, we say to find the common difference here, we say we have T2 minus T1. And I said, at any time an expression has a constant common difference, we can call this particular expression as what? As a linear sequence. Alright? So, we say T2 minus T1. Now, what do we have for T2 here? We have 5. So T2 here is, let me say T2 minus T1. And T2 here is 5 minus T1. What is T1? Is 3. And 5 minus 3 here is equal to 2. Alright? Suppose we take T4 minus T3. Now we say this is T4 here minus T3 here. What is T4? From the expression here, T4 is 9. Now we can say this is 9 minus, and T3 is what? Is 7. So 9 minus 7 here is equal to, we say 9 minus 7 is equal to what? Is equal to 2. Alright? Now again, T3 minus T2. T3 here minus T2 is, okay, so T3, what do we have for T3? We have 7 minus, what do we have for T2? We say 5. And 7 minus 5 is equal to, we say 2. So if you take a look at this particular expression here, we have a constant common difference, which is what? 2. So therefore we can call this particular expression as what? As a linear sequence. Alright? Now, let's look at the top. What we have at the top here? Also, let's say T2 minus T1. What we have as T2, we say 4 minus T1 here is 2. And 4 minus 2 is equal to 2. Let's take from this part to this part. T3 minus T2. What is T3? Is 6 minus what is T2? Is 4. This one is equal to 2. So we take again T4 minus T3. And T4 here for the top is what? Is 8 minus T3 is what? Is 6. And 8 minus 6 is 2. So you can find out that we have a constant common difference. So since we have a constant common difference, we can call this expression as what? As a linear sequence. Alright? So, for the linear sequence here, we say we have a formula that we are going to use to solve problems or to find what the nth term. And what is that formula? For the linear sequence, we say we have nth term here, or we say Tn. Say Tn here is equal to, we have A plus in brackets n minus 1d. That is the formula that we are going to use to solve problems on what? The linear sequence. And let's look at the term here. We say Tn here is equal to the last term. Alright. And we have A here. A is equal to the first term. The first term. And we have N here. N is equal to the number of terms. And we have 1 here minus 1 here is a constant. And we have D. So D here is equal to a common difference. Now we have known how to find what's a common difference, right? Always come from the back to what? To the front. So these are the terms. Now we say Tn is the last term. Now say N is the first term, and N is the number of term, and D is what is the common difference. Minus 1 here is what is the constant. Alright? But why do we say A is the first term? Let's prove something here. Since we have the formula here, we say A is the first term, even though I am going to give you another formulas that we are going to use to solve problems for the nth term. To solve problems on what? The linear sequence. Alright? Now, since we say A is the first term, why do we say A is the first term? What is the first term here? First thing is what? 1. Right? It's the first term. Alright? So in this case here, suppose we say when n is equal to 1, right? Now let's use this formula. Let's use this formula which says what? Say Tn here is equal to A plus in bracket n minus 1d. So in this case, according to the formula here, we say when n is equal to 1, so where we see n, what do? We place 1. So we say this is T1 because n is what? Is 1. So where we see n, we substitute the value of n is equal to A. Do we know A? No. We say this is A here plus in brackets n is what? We say 1 minus 1. And we have D. Alright. Now we go. Now this is T1 here is equal to, we have A plus 1 minus 1 is 0, and we bring down D. Now we have T1. Now we say T1 here must be equal to, we have A here plus 0 times D is what? Is 0. And we have T1 here is equal to, now A plus 0 is A. So you see, we said A is what is the first term, so therefore T1 is equal to what? A. Alright? And mind you also, we say T2 here is equal to A plus D. And we say T3 here is equal to A plus 2D. And T4 is equal to A plus 3D. T5 here is equal to A plus 4D. This is how we have it terms. Alright? To have all of these proofs, then you can use your formula. Beg your pardon? Now we say when n here is equal to 2. Now the formula says what? Tn is equal to A plus in bracket n minus 1 D. Alright? Now we have T, but n here is equal to what? N is 2. Is equal to A, the first term, we do A. So we bring on A here plus in bracket. We have what? Inside the bracket we have n. What is n? N is now 2 minus 1. We have D. Now we say this is T2 here is equal to, we have A plus 2 minus 1 here is what? Is 1. We bring on D. Now we say this is T2 here is equal to, we have A plus 1 times D is D. So therefore when we say T2 is equal to A plus D, that's how we got T2 is equal to A plus D. Suppose we want to find this one also. Now we say when n is equal to 3. But from the formula we say what? Tn is equal to A plus in bracket n minus 1a. Alright. Now when we see n, what do we do? We place 3. So we say this is T3 here is equal to A plus in brackets, we have 3 minus 1D, because n is equal to what? 3. Now we say this is T3 is equal to, we have A plus in bracket, 3 minus 1 is 2 here, and we have D. Now we say this is T3 here is equal to A plus 2 times D, we have 2D. So this is how we got these values. Alright? Like I said, this is one formula that we are going to use to find problems on our the sequence. Now we go. Let me give you the other formulas that you are going to find in the remaining now. You are going to find T4 and T5. The simple logic there is, even if we have, let me say, n here is equal to 100, just subtract 1 from this formula. If you have n here is equal to 99, just subtract 1 from this formula, because you already know that n is 1, right? So we now say what? 99 minus 1. Therefore, we now have A plus, so the first one here we have A plus 99D. Alright? And here this is what? T100 is equal to A plus 99D. And T99 is equal to A plus 98D. Alright? But let's give you another formula that we can use to solve problems under the linear sequence. Now, what is that formula? Now the formula is what? We say the nth term here is equal to, now we say this is dn here plus in bracket a minus d. So the nth term is equal to dn plus in bracket a minus d. According to this interpretation here, we say a is the first term, and here also we have a. We say n here is what is the number of term, which is here also, and we say d is what is the common difference. So we have all of the formulas there. Alright? Suppose we want to use this formula here to find the first term. That is T1 here is equal to A, as we likely said here. Alright, now suppose we want to use this formula. I can tell you that this formula and this formula, they are just the same. Alright, and again, we have another formula which says, now this area is equal to, now this area of A1 here plus, what do we have here? We have D here into what? Say N minus 1. This formula also, you can use this formula here to find problems on what? To solve problems on what? On the linear sequence. Now let's find the first term. Here we say T1 is equal to A. Let's use this formula here to prove it. Now we say when N is equal to 1. Now I mean the nth term here is equal to say Dn plus A minus D. Now we say the nth term here, what is N? N is 1. So the nth term here is equal to, we have D here into N. What is N? N is 1 plus A here minus D. Alright, now we go to the first term here is equal to, now 1 times D is the same as D. Plus, here we have A minus D. The plus times plus here is what is plus, and plus times minus is minus. Now we have the first term here is equal to, now mind you, we have D here and we also have D here. Alright, so therefore we can say this is A here plus, what do we have here? We have minus D here. Let me say A here, this we have plus D, we have minus what? Minus D. Let's rearrange them, which we have done. Now so the first term is equal to, now we say A here plus D minus D is what? It's 0. And we have the first term here, A plus 0 is the same as what? It's equal to A. So when we use that formula, and when we use this formula, we are going to have the same answer. Alright, so in this case here, let's try to use this formula at all. We are going to have the same expression. Alright, we say when n is equal to 1. We say Tn here is equal to, we have A1 here plus, we have D into say n minus 1. This formula also can have the same answer. Alright, now when n is equal to 1, right? We say this is T1 here is equal to, we have A plus D. Now what do we have here? We have N, Now so this is N here. N is what? 1 minus 1. Now so this is what? Say T1 here is equal to A here plus, we have D, we have D. 1 minus 1 is what? Is 0. Alright, now we have T1 here is equal to A plus D times 0 is what? It's 0. Now we have T1 here is equal to A plus 0 is 3. So irrespective of the formula that we use, we are going to have the same answer. So we now have 3 formulas today to solve problems under linear sequence, or we say what? AP. Alright, that is the arithmetic progression. So we now have 3 formulas to solve problems in it. Though I am going to solve problems using what? All of the formulas. I know you have used to these formulas already. So I am going to focus on this formula and this formula. Alright? So now, again, what are we going to do here? I'm going to leave another assignment with you. Now, we have the formula here which says what? Tn is equal to A plus, in brackets, n minus 1d. Alright? But let's prove this formula. Okay? Now we have been solving problems on the linear sequence using this formula. Let's prove the formula now. Now we say T1. Now we say this is T1 here. And let me have here T2, which is the second term. Let me have T3 here. And I am going to have T4 and T5 here. I have what? Tn. Alright? But mind you, we say the first term here, T1 here is equal to what? It's A. And we say the second term, which is T2, is A plus D. And we say the third term, which is T3, is A plus 2D. And we say the third term, so the fourth term, T4 is what? A plus 3D. The fourth term here is what? So the fifth term is A plus 4D. We have dot, dot, dot. And we have Tn. Now how do you have Tn? Which is this formula here? Now the Tn here is equal to A plus a bracket n minus 1D. Now we have Tn here. We have T1 as what? As A. We have T2 as A plus B, which we have done just now. We have T3 as what? As A plus 2D. And we have T4 as what? As A plus 3D. We have T5 as A plus 4D. Dot, dot, dot. It's continuous, right? And we have Tn. Now, what do we have for Tn? We have nothing. But how we have value for Tn here? Let's go again to our work. Let's revisit our work here. Now, if you take a look at the expression here, now we have 5 here. Mind you, here this term here is 1 less than the term. The common difference here that we have here is 1 less than what the term that we have. Right? That is, we have 4 here, and here we have 5. Here also, what do we have? We have 4 here as the term, but the common difference here is what? Is 3. Here also, we have 3 as the term, but the common difference is what? Is 2. It means it is 1 less than what? The term. Here also we have what? We have 2 as the term, but the common difference here is what? Is 1. Alright? So it is 1 less than the term. Here also we have what? We have 1. And what do we have? 0 for what? For D. No common difference. Alright? So in this case, if we have to subtract, alright, this is just the same as what? We have here 5, eh? This is just the same as what? 5 minus what? Minus this common difference. Alright? But again, all of this expression here has what? The first term. Alright? Here we have A, here we have A, here we also have what? A, and here we have A. All of the terms has what? The first term. A, eh? So in this case here, we can say this is A, and I have the sign A plus. Alright? Now, looking at the expression like I said earlier on, we say each expression here, each term here is 1 less than what? The common difference. Alright? So therefore I can say in brackets. Hope we understand the concept here. Now, we say it's 1 less, the common difference here is 1 less than the term that we have. Here we have the 5th term, and the 5th term here is what? 5. Sorry, we have the 5th term, and the common difference is 1 less than what? The 5th term. That is 4, eh? Now here, what do you observe? The term here is, here we have T5, here we have Tn. So we can take n here minus, because this is the same as what? As T5 here minus what? The common, minus what we have here, the common difference, which is what? Minus 4. Alright? So if you say T5 minus 4 here, what are we going to have? The common difference. Now this, sorry, T5 here minus what? Minus 1. And T5 minus 1 here, we are going to have what? 4 as an answer. So likewise here, you can see this is n here less than. You say minus what? Minus 1 here. This common difference, D. You say minus 1D. So at all, what we have Tn here, for this one here, is equal to, here we have A plus, in bracket, we say n minus 1D. This is how we obtain the formula. Let me explain. Now, let me just shorten this one. Let me just make this one to 2. Now, we have this dot, 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 and here we have what? Tn. Alright? Dot, 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 here we have Tn. Okay? But, we say here we have A, eh? So here for this this one also dot dot dot, here we have a, but a plus, right? And because why we say a plus, because all of these terms here has the expression. Alright, now looking at the expression here we have the first term, and here we have what? Common difference, we have nothing. Here we have the second term, which is T2. For the common difference, we have only one. It means it is 1 less than 1. The common difference is 1 less than 1. The term. Just like we have what? We have this one. This is T3 here minus 1. Here we have T2 minus 1. Here we have T1 here minus 1. Alright. Now here also we say dot dot dot. Let's see what? We have T here. We say Tn here. Now we say this one is equal to, that's the last term, eh? Now we say we have A. We say A here plus a bracket. Alright? Now we say what we have here, we say the term here is what is n minus 1. We have what? We have d. Why? Because all of this term here, we say this is 3. 3 minus 1, we have what? We have 2, eh? So here also we say n minus 1 here, we are going to have this value. It's just the same as what? As n here, this is Tn here minus what? Minus 1. Alright? Because we say this is T3 here, which is the term minus 1. Here we have Tn here, which is the term here minus 1. Minus 1. So this is how we obtain this formula that we solve problems on